Hey everyone, thank you for joining today. We're going to be talking about continuous delivery and how to apply continuous delivery to database schema with a specific focus on reducing risk and accelerating application development by pipelining all the things. To get started, imagine that you are a software engineer at an early stage e-commerce company. Now, the company's small, we're early stage, so the engineering team is lean and mean, and you've been frugal in terms of your application infrastructure. So the website is backed by a single Postgres instance. Maybe we have replication to another standby for failover. You spent a little bit of time on building out some release pipelines for the web application itself, but database changes are just made manually because they're relatively infrequent. So it's a very manual process to update database schema. You've been working hard and are in the last mile of this feature that's going to add a new customer loyalty program. So when customers spend money on the website, they accumulate loyalty points and they get free stuff. Who doesn't like free stuff? So you're deploying this change to production, which involves modifying schema. So you SSH into that Postgres instance and you start running SQL commands to alter the table and add a column. You didn't think this was very risky because it was just an additive change, but when you try to run that command, terminal locks up, you're waiting. Out of the corner of your eye, you see an email come in that's an alert that the live site is having issues. And all of a sudden you realize that the entire live site is down. So you start sweating bullets, other engineers get involved, they're trying to figure out what the problem is. The site's totally unresponsive until finally that command times out and the terminal's back and all of a sudden the live site's back. If you're listening to this talk, I'm guessing this doesn't sound completely foreign to you and you've been involved in some type of issue like this related to making a manual change to a database schema. I know that I certainly have. This is familiar territory for me. My name's Tyson Trautmann. I studied computer science and business. I've been working in software for about 2.5 decades, mostly focused on managing large-scale distributed systems and building tools to make developers more productive. I did this at Microsoft, working on Bing's infrastructure, at Amazon in their internal builder tools team, at Riot on the infrastructure platform team, where the common thread between all three was really focused on allowing internal development teams to innovate. Then I went back to Amazon to join AWS as the general manager for Code Pipeline and Code Deploy, really focused on consulting with Fortune 500 companies and helping them to think about release automation and getting their software to production safely. Now I'm the VP of engineering at a database company called Fauna, where we're building the ideal operational database for modern application developers. So this talk really brings together two of my passions, which is continuous delivery and databases. Also note that particularly during my time at Riot, when we were really hyperscaling the company and working with pretty lean teams, we saw a number of notable production issues caused by database changes. So the example that we talked about in the intro really is near and dear to me in particular. Okay, so before we dive into the meat and potatoes, I want to talk about what we're going to cover for the next 15-ish minutes. So by the time we get done with this talk today, I want you to be able to answer 4 different questions. The first is, what is continuous delivery? Maybe this is old hat for you. I think some of you may be familiar with continuous delivery, but really a big deal in terms of state of the art in shipping software safely. So important to understand exactly what continuous delivery or CD is. Second, what is it about databases that makes continuous delivery hard to apply to databases? Third, if you get past those hurdles about what makes it difficult, how do I actually go about applying continuous delivery to databases and specifically to data schemas stored in a database? There are a few aspects to this. We're going to talk about requirements for tooling that you use, and then we're going to talk about once you have the right tooling in place, how do you actually go about implementing CD for databases? And then finally, I want to spend just a little bit of time talking about what modern database offerings like Fauna bring to the table and how they make it a lot easier to practice continuous delivery when it comes to your database. Okay, let's dive in. So first off, what is continuous delivery? Fundamentally, CD is the ability to release software changes safely and quickly at any time. This is a radical shift from traditional methods of shipping software where changes were batched up into large batches and then deployed to production using kind of very one-off methods. But there was never a way to just take individual changes and quickly and safely ship them by themselves. It really fundamentally requires rethinking both the inner loop, where you're developing a software change locally, going through that code, build, test cycle, to the outer loop where you're happy with the change locally, and then you're thinking about how to get that change to production by integrating it with other code changes, testing it in the context of other code and dependencies, and then releasing and deploying it to production. So all of that is in scope when you think about continuous delivery. If you can get it right, CD comes with a bunch of major benefits, including reduced deployment risk through smaller, more incremental changes, faster time to market for new features and also for bug fixes as well, and improved product quality because you have automated testing at every stage of the pipeline. If you want to go deeper into the benefits, I highly recommend checking out the book Accelerate by Nicole Forsgren and Jez Humble. It's a great read that really talks about in detail what CD brings to the table for software development teams. So all that sounds great. Why would people not do this when it comes to their data and their database? The answer is there are a bunch of things about databases that make it harder to apply continuous delivery. And we're going to call out 4 of them in particular. So first off, databases are stateful. In fact, you could say they're supremely stateful. They really are the place where we're storing application state. So unlike your application itself, which is often stateless or relatively stateless, you can just kill it, you can deploy a new version, you can roll back to the prior version. Every change when it comes to your data, and that's in your schema associated with your data, is a state change. That can be complex. You have to make sure you have a valid path from one state to the next state and backwards if you need to roll back. So non-trivial, and you potentially run the risk of data loss or data corruption as you make those changes. I'll defer to my friend Calvin down here in the slide where he says, you don't fully appreciate life until you risk losing it. That's not the attitude that most of us take towards our production data. The second thing, I'll just call it a few others quickly here. The second thing, databases often need to provide strong consistency and isolation guarantees, which is usually accomplished through support for transactions. Those transactions are also often coupled with longer lived sessions. The database may need to hold locks in order to make these isolation guarantees. And so the deployment mechanism needs to interact with those mechanisms that the database is using to provide consistency and isolation, which is not trivial. Third thing, the process of orchestrating the changes themselves is often very complex. So you have services that are consuming that data, and you have to think about the sequencing of getting schema changes to production along with changes to consuming services. And then the final thing is that most modern databases have very limited tooling available in terms of the kind of capabilities that you really want. And we'll talk about this in more detail in order to bring continuous delivery to data. So in practice, that means a lot of times you have to bring in different third-party tooling from additional vendors, which adds complexity when it comes to the deployment process. And those tools also often lack the ability to easily map changes in schema to different environments, from development locally through pre-production and then all the way to production. So a number of challenges associated with bringing CD to databases, but not insurmountable. So we hit on some of the difficulties when it comes to practicing continuous delivery for databases, but it's not impossible. If you want to practice CD for your database, you need to start by thinking about a core set of requirements that you have for the database itself and any other associated tooling that you're using to interact with the data. I'm going to hit on 4 key requirements that set of tooling needs to support. The first is programmatic schema support using something that we call schema as code. So if you think about the type of mindset you have when you're programmatically interacting with your infrastructure using infrastructure as code, this is similar. So your schema is defined in source code that can be applied, or changes can be applied in a very repeatable way. And that source code can and should live in repositories along with your production application code. The second requirement is tooling integration that supports both the inner and outer loop that we talked about earlier. So tooling that has seamless integration with your other existing CD tools and processes that you're running. And it can be applied to every step in both that inner loop when you're doing local development and then the outer loop of taking that change to production, validating, etc. The third requirement is transactional changes and then also support for rollbacks. So changes are applied in a transactional way that doesn't violate those consistency and isolation requirements that we talked about earlier. And the database has the ability to roll changes back if needed if a schema change causes issues in production. And then the fourth change I'm going to spend a little bit more time on because I think it's arguably the most important is the ability to perform comprehensive validation in each of your environments, again, ranging from dev to pre-prod all the way to production. And really what that means in detail is that you're validating your modified schema a few ways. First of all, you're validating that it's compatible with existing data, particularly in production. Second, you're validating that it's compatible against consuming services. And then third, you're validating that the path to get from that old schema to that new schema makes sense and will happen without any errors. So if you flash back with me to that story that we told in the intro to the talk, if you go to the next level of detail, what happened in that story that I was setting up is when you actually went to apply this alter table command, the SQL command, that table requested an access exclusive lock to the customers table to make that schema change. During that time, there was a long-running analytical query in the environment that had an access share lock to that table. So it didn't allow your alter table command to complete. It sat behind it in a queue, and it blocked all other requests to that specific table, which effectively caused production downtime. So that issue with getting from an old schema version to a new schema version could have been detected in a pre-production environment, but the pre-prod environment would have needed to include things like production-like analytical queries running in that environment, right? So something to think about when you're performing this type of validation, you need to make sure that that environment looks as close to production as possible. So let's assume that we have all these requirements in place and we're ready to go actually implement continuous delivery. What do we do? I'm going to call out 5 specific steps that you can take to start implementing continuous delivery for your database schema. The first is by building release pipelines for database schema. And I want you to start thinking through this lens of seeing everything that goes to production as a pipeline. The reason is a pipeline is a set of programmatic repeatable steps that also gives you a good place to plug in automated validation as part of that release process. And so what you're actually looking at on this slide is a pipeline that we use at Fauna. So we're huge believers in eating our own dog food. So we leverage Fauna as the database behind many aspects of our managed service. Unsurprisingly, we're also huge believers in continuous delivery. And so we typically release application and database schema changes through these pipelines. So this pipeline right here in particular is actually the pipeline that for some of the services that back our backup and restore functionality. And part of what this pipeline is doing is applying database schema changes in 3 different environments. So I won't go into too much detail, but you see kind of a branch here in the pipeline where we're deploying to 2 different environments in parallel, performing different types of validation in those environments, and then assuming that everything goes smoothly, that change will go ahead and make it onto production. So pipelines are a huge deal. I realized, by the way, that this pipeline can look, it's kind of intimidating. Like, how do I build this up from scratch? I'm going to channel my friend Calvin here in the slide who says that instant gratification is a myth. All of this takes time to implement. So be patient, start with small steps, implement a simple pipeline, and then build from there. That's what we did in this specific case as well. So the other 4 things I want to touch on, the second item here, version controlling your schema. Again, we talked about this earlier as a database requirement, but take advantage of that schema as code capability by defining your schema in source code and putting that with your application. So if you use Git and GitHub for your application code, put your database schema along with your application code in GitHub, and implement branching and merging strategies as well for your kind of schema development workflows. The next one, the third one here, is adding automated tests. So make sure that you're performing the types of validation that we talked about earlier for those schema changes as they make it to production. Fourth one is applying zero downtime migration strategies for the database. So as you move towards releasing smaller changes more frequently, it's obviously going to be unacceptable to take database downtime as each of these changes rolls out to production. And so you need to leverage a database that can apply those changes in a way that doesn't cause production downtime, no matter what type of action you're taking on your schema. And then finally, and critically, make sure that you have a robust suite of monitoring and observability in production, including things like canary tests validating core scenarios in production so that if your schema causes an issue, you can detect it and take action accordingly. So I want to talk just a little bit about Fauna and some of the things that we've done at Fauna and our unique capabilities that make it easier to apply continuous delivery to databases. I touched on this earlier, but Fauna is an operational database that's kind of ideally suited for modern application development. It has a number of capabilities that are directly related to practicing continuous delivery for database schema, including schema as code support via what we call the Fauna schema language, which is what you see on the right here. You see just a little snippet of FSL kind of showing you what that's about. It gives you the ability to optionally define schema over time that will be enforced in the database. Fauna also has a powerful command line interface that provides the ability to both define different endpoints for your environments as you're practicing CD from dev, pre-prod through prod. And you can use those endpoints to push schema changes and also to load sample data. So if you have kind of known deterministic data that you want to load as part of validation, you can do that in your different environments as well. I think maybe the most exciting one from this list is the third bullet, which is support for zero downtime migration. So you see a little example of that in the FSL snippet here, where there's a couple of simple migrations to just do a rename and a backfill. But fundamentally, the way to think about migrations is there are a set of imperative steps that you are running to get your schema from one state to the next. And Fauna will look at those migration steps. It will ensure that they're valid and that they will complete successfully before applying them. So you'll never end up in a bad state. And it will always apply them with zero downtime. So schema changes are applied transactionally, and there's no locking or anything like that. Changes are applied just in time for subsequent requests that come in. And then if needed, Fauna will kick off an async process to go and actually manipulate data on disk to optimize subsequent transactions. So really cool set of capabilities there to avoid the downtime that comes with some of these other databases. And then finally, Fauna also provides built-in validation and safety checks through features like computed fields and check constraints that, again, I'm not going to go into detail here, but very powerful concepts. So to kind of wrap up here, first off, regardless of which database and which set of tools you choose, there's a few things that I would urge you to do. The first is, like we talked about, understand continuous delivery, the power of it, all the benefits that come with it, and specifically think about what it can bring to your database schema. Second, think about how you would go about applying continuous delivery to your database schema if you don't already today. So, think about the tooling requirements that we laid out and the steps to implement that, and start small. Implement something. Again, you don't have to go and build out these elaborate, robust pipelines on day one. Start by automating something and then come up with a roadmap to build out from there. And then finally, constantly look at tools that are out there in terms of practicing the state of the art for continuous delivery, and weigh the pros and cons of those different tools. Nobody's super hungry to go out and do a full database migration. That can be a lot of work, but you never know. It may be worth it. Or bringing another database alongside your existing database for specific use cases may make sense given the capabilities that database offers. So be aware of the landscape, evaluate the landscape, and be sure that you're considering the right tools to optimize the way that you could run continuous delivery for your database schema. Finally, I just wanted to give a little tip of the cap to kind of what's next and where things are headed in this space. If I was going to peek around the corner and say what's going to be exciting in continuous delivery, and specifically for databases over the next few years, one of the things we were thinking about at Amazon was more dynamic pipelines that kind of understand application and service dependencies and the pipeline can be dynamically constructed to optimally get that change to production, thinking about things like when schema changes, what services need to change that are associated with that schema. So really powerful, and it's a hard thing for humans to reason about in real time. I think that AI, obviously the buzzword of the day, but AI maybe has a place here too, where an AI could have the capability to introspect a combination of like production runtime dependencies, code dependencies, et cetera, and just optimize a path to production. So very exciting possibilities. I'm a little bit dubious as long as we have human operators in the loop about how you would operate those dynamic pipelines and reason about problematic releases and rollbacks. So a lot of hard hurdles to overcome, but probably some very exciting things coming down the pipe over the next few years there. So that's it for today. I really appreciate your time. I appreciate you hanging out with me and talking about continuous delivery and databases. If you're excited about this topic and you want to nerd out further, I'm all about it. My contact info is on the slide. Email is tyson@fauna.com. You have my Twitter handle here as well. So feel free to drop me a DM there. Or if you want to look into Fauna, go check out fauna.com. You can look into some of those capabilities that I discussed earlier and see what they're all about. So again, thank you and best of luck as you're implementing continuous delivery for your database schema.